just a minute, over at W. Just a minute, just 2 minutes. Okay. I've slightly lift it now. Just a minute. Okay. I think further adjustment is not required. It is crystal clear. Problem visible. Everything visible. Okay. Just a minute. 46, 14, 8, 14. Okay. Okay. Just let me know. As usual, I have to hide the mic. Is voice clear? Voice clear? Respond fast. If voice clear, I will start. I am doing YouTube because this will not be deleted. It's a first question on settlement. So permanent, any day you can remember it. See, if Zoom I do it, first I thought of continuing Zoom only. This particular part, because any day, suppose even if I delete the Zoom, this will be always there. So advantage for you. Others also will learn. Okay, voice clear? Okay. Now, make a note. Analysis of continuous beams with support settlement. Now, before I start, I already told you what is support settlement. See, when a beam is resting here on a support, if the support is very rigid, then actually practically no support is 100% rigid. Or, see, from the beam to the supporting member, a load is transferred. When you transfer the load, that member gets compressed. That member gets compressed. When that member gets compressed, like a column supporting a beam, column gets slightly compressed. Then how much it gets compressed, that much the beam will sink. Very small amount. Clear? How much the column gets compressed, that much the beam will sink. Yes or no? Fast. Suppose a column gets compressed by 10 mm. Beam will sink by 10 mm. Clear? Okay. This I already told you earlier. See, long back I told. Today I won't tell much. Now, it has got effect on the beam because you know that when support settlement is there, fixed end moment will be developed. So here we have to consider FEMs due to loading and also FEMs due to settlement of supports. I will explain one by one. See, first, this is a question. I already solved the question. You can see somewhere there scattered numbers. This is actually for my reference only. Scattered number means in the corner I already solved it to save the time. So that calculation part not much for you except little. Okay, start. See, I am doing one thing. I am taking master question where every support is settling. Academic point of view, usually they give one support settlement. After completing this master question, I will explain if a particular support settles, what happens. So today is master question, and in the master question, I am including the overhang also because there is a reason. These settlements has no effect on the overhang. So whether this overhang portion has nothing to do with the settlement. So this moment will be, see, you know the answer, minus 54.72. It will remain same. Anyway, let us solve systematically. Now, question, analyze and sketch SFD-BMD if support at A rises by 8 mm. Now, somebody will ask, sir, rising, how it is possible? Actually, usually not possible. Why I want is, I want one question. See, when I give the values here, my purpose is to make understand. I have seen academic questions. Rarely they tell support rises. Some will get confused. So rises means what? It goes up. So important is what? Or suppose, see, if very heavy moment comes here, then it will try to lift the support up. Then settlement will be slightly upward. Anyway, you need not bother. In structural analysis, whatever data given, because someone is bound to ask, how rises? I will tell, I told it rises. Keep quiet and solve the question. That's all. See, nobody can question why you gave rises. Purpose is to understand the concept. Usually sinking is down. Leave it. Support at A rises by 8 mm. Support at B and C and D, all of them sink respectively by 14 mm, 4 mm and 20 mm. Okay. Then remember, when support, so far I used to give 2 EI, 3 EI, EI like that. That theta will come in terms of EI. EI value is not required. But when settlement is there, you require numerical value of EI. What is the reason? Because the fixed end moment is 6 EI delta by L square. So whenever the settlement is given numerically, you require numerical value of EI. But sometimes after this question is over, one small question I will solve in single class by all three methods. SD method, MD method, Kani's method, small question, where I will give settlement in terms of EI. If the settlement is given in terms of EI, then numerical EI is not required, because when you substitute for 6 EI delta by L square, if they give delta in terms of EI, like 100 by EI, etc., EI gets cancelled. That you can make out later. So therefore, in the question given, E is 200 GPa and I is 8000 centimeter power 4. First make a note, one important note. We are solving the question in kilonewton and meter unit. Remember, we will solve the question in kilonewton and meter unit. So when you substitute, everything should be in terms of kilonewton and meter. Means force should be in kilonewton. All linear dimensions, distances should be in meter. Okay, leave it. Now, SD method today I am doing. That's all. See, first step for SD method. For a prismatic member XY, MXY equal to M bar XY plus 2EI by L into 2 theta X plus theta Y. See, red color, plus or minus 3 delta by L. I told you earlier, in all the previous 9 questions, settlement was not given, delta was 0. But this time, delta is there. Therefore, you have to consider this term also, class. Earlier question we stop here, 2 theta X plus theta Y. But here, because of settlement given, you have to consider plus or minus. I will explain to you. I will explain this term. What is the sign convention? Plus or minus 3 delta by L. Clear? Delta term also will come. Clear? Now even delta term also will come. Clear? Little fast you have to tell, because I have to leave the class at least by 9. I have to finish today. I cannot go beyond 9 today. Clear? Okay. Now, some important concept I am telling. I wrote class. What all I tell, you should write it. Okay, start. Now, first note. This is the equation when both ends of member are supported. Therefore, remember, this equation you can use for AB, BC and CD, but not for DE. Very important. You cannot use this equation for DE. So only when both ends are supported. Okay, now you also know that when the far end is free end, mxy equal to m bar xy, that's all. Mxy equal to m bar xy when far end is free end, class. That's all. Delta, nothing like that. Just 1 minute. Some echo is coming. I just close the echo. Because I am simultaneously watching by other mobile. It is giving sound. 1 minute. Once again, same thing. I have to adjust the mic till I get the clip. The clip I tried today, I will give you after 2 days. Okay, then for 2 days, I have to adjust somewhere this way only. Okay, now, so make a note. When the far end is free end, that is for DE member at D, m bar MDE equal to m bar DE. That's all. Nothing. No delta, no theta. I tell you sometime for fun. Support, sinking, rising, dancing, rotating, none of them considered for DE, because mxy equal to only m bar xy. Use this one for the member DE, at D. Clear? I will not tell again. This I told you. Delta, gilta, ulta, nothing. Theta, gita, uta, nothing for overhang. Okay, start. Now, class, this is equation. Now see, sign I will tell you. One very important concept. Here, thetas are unknown. Tell me, delta is known or unknown? Tell the answer. Delta is known or unknown? First. This is the question of analysis of continuous beam for given support settlement. I forgot heading. Not unknown. For given settlement. Delta is known or unknown? Tell me. Delta is known or unknown? First. It's not time to decide. Delta is known. Therefore, see, later when you go to frames, there also delta will come. That is because of sway. At that time, delta is unknown. Therefore, it will remain here only. Delta by L square. Or that much not required. You know the answer. This is the term fixed end moment due to delta. You know the answer. 6CI delta by L square. See, This 6ei delta by L square, when you took 2ei by L outside, we wrote 3 delta by L. You write what the term is side. Clear? Fast. Okay. Now, next important. How to decide sign for this plus minus? I will tell only once in the class today, because earlier when I explained FEM, hundreds of times I explained. So many people, they will tell you if the right support sinks with respect to left support, delta is minus. If the left support sinks with respect to right side, delta is plus. Very sorry, that is wrong concept. I am not hurting them. They should know one thing. All these are momentums. You do not give sign for delta. It is a wrong concept. You should not do that way. In case of frame, they will have difficulty. Correct concept is, you write here. See, I will dictate here. You write here. I will dictate here. How to decide sign for this term? 6ei delta by L square. What I am telling now is valid for SD method, MD method, and also for Kani's method. When I go to SD and Kani, I will tell you, refer. When I go to MD and Kani, I will tell you, refer back to SD method. Okay. First of all, note, 6ei delta by L square is fixed end moment due to delta or support settlement. So this term is fixed end moment. This is the fixed end moment due to loading. This is fixed end moment due to delta. Therefore, you write a proper sketch. There, clearly show delta. Clearly show delta, and then you correctly consider the elastic curve for that member and decide, very important, and decide, I will not tell again, whether fixed end moments due to delta are clockwise or anti-clockwise. You decide whether, I am not repeating once again, go through this class again and again, whether fixed end moment due to delta are clockwise or anti-clockwise. Our sign is clockwise positive. Therefore, if the fixed end moment is clockwise, use what sign? Tell me. If the fixed end moment is clockwise, use what sign? That is the correct concept. Using sign for delta is a wrong concept. If the fixed end moment due delta, if the fixed end moment, okay, the voice clear? If the fixed, any voice problem? Is the voice clear? Now clear? Is the voice clear now? Is the voice clear now? Now it's okay. So remember, I will not tell again and again. To decide sign for this term, you decide whether the fixed end moment due to delta, not loading, delta is clockwise or anti-clockwise. If it is clockwise, use positive sign. If it is anti-clockwise, use negative sign. Shall I close the matter? Shall I close the matter once for all? If the FEM due to delta, after drawing elastic curve, showing delta for the member, if the FEMs are clockwise, use positive sign. If FEMs are anti-clockwise, use negative sign. And one more thing, remember, due to loading, one side will be anti-clockwise, one side will be clockwise. But due to delta, both ends are same direction. And I told some more thing earlier. Go back. General public also can go back. You remember it as preventing case. Remember, preventing case. If member tilts this way, FEMs are anti-clockwise. Preventing case. If it slips this way, to equal or to maintain once again back, see, you require this way. Preventing case. Yes, okay, sufficient. Those who are in my batch, they will understand. First of all, general public also. This is told earlier very thoroughly while finding FEM. Leave it now. Stop. Now, therefore, see, now start. First, calculation of FEMs considering loading, that is this term, M bar. Happily calculate. No problem. AB, UDL, anti-clockwise, clockwise. BC, anti-clockwise, clockwise. CD, anti-clockwise, clockwise. Clockwise. And overhanging side, see, load will try to go this way. FEM is anti-clockwise. Is the FEM due to loading fully clear? I'll remove it. First of all, I should not waste time for FEM due to loading. Fully clear? FEM due to loading. Fully clear? Okay. Now go to next term. Okay. I am rubbing everything now. Anyway, I noted the answer in the corner there. Okay. This I will not remove. Okay. This I will remove. This is not required now. Okay. Start. Now, what all I should remove? I will see now. See. I want more space. Therefore, here also, question is still there. Prismatic member story, I am removing it now. Prismatic story, I am removing now. Why? Already explained for you. Okay. Already explained. I am removing that story or this I am not removing. Okay, now further. Little more unmute. Now, 1 minute. See, correctly observe. This term is over. Unknown term, you remember first. See, A, absolutely fixed. Therefore, theta A equal to 0, over. See, this comes in 9 basic questions, correct? This comes in 9 basic questions, yes or no? 9 basic questions, whatever I told is still valid. Clear? This comes in 9 basic questions. Clear? Fast. I should not explain further, waste time on this one. 9 basic questions over. Okay, start. Now, theta A is 0. So, unknowns are going to be theta B. So, you can make a note. Your unknowns are going to be theta B, theta C and theta D are going to be the unknowns. Okay, leave it. That all very later. Or I'll tell now only. When I write AB and BA, put theta A 0. Theta B will come. When I write BC and CB, put theta B, theta C, both will come. When I consider CD and DC, theta C, theta D, both will come. When I put D, nothing will come because theta, geta, uta, nothing there. Delta, gilta, nothing. MD equal to M bar D. Which M bar D? Only loading M bar D. Delta has no effect on the overhang. Okay. Now, before you substitute, make a note. Delta is known. We need numerical value of EI. Numerical value of EI. Yes or no? We require numerical value of EI. Tell yes or no? Numerical value of EI. Fast. Time is not there today. Yes, and if we want it in kilonewton and meter unit. Therefore, I will write here, given in the question, what? E equal to 200 GPa. I equal to 8000 centimeter power 4. You do whatever you want here. Unit conversion, you should do it. I cannot waste time for structural engineers. This already I explained earlier. So, correctly get EI equal to, correctly solve, your EI will come 16,000. I already know the answer. Kilonewton meter square will come. This you have to get it. No problem. Tell me. If problem is, stop the class right now. Don't come any of my class. Clear? EI will come 16,000 kilonewton meter square. Tell me, clear or not? Fast. Don't waste time. Clear? Oh, okay, got it. Okay, now leave it. Now, this is also over. Now, systematically start. Before starting, see, this delta should be known. You should know, earlier class I told what is delta. It is not directly sinking. Relative settlement. I told you earlier. See, suppose long back in the same YouTube only I had taken a class, if you remember, where everything explained. People have to refer that one. See, tell me. Suppose this is the member. If this sinks by 3 mm, if this sinks by 8 mm, tell delta. Delta is relative displacement of one end with respect to other. It is neither 3 nor 8. Tell delta. First of all, I won't waste time. Why? This is so thoroughly explained earlier. In the YouTube only it is there. Answer delta. Delta. If this sinks by 3 mm, that sinks by 8 mm. Delta. How much? Delta is 5 millimeter. Now, suppose this sinks by 6 mm. This is not sinking. Delta. Displacement of one end, vertical displacement of one end with respect to other for beams. Delta. If this sinks by 6 mm, that is not sinking. 6 mm only. Or suppose this is not sinking, that sinks by 7 mm. Delta from here to here, 7 mm. And also, suppose this sinks by 3 mm, that goes up by 4 mm. This will come down here, that will go up here. Tell me delta. I told you. One will go down 3 floors down, other will go 4 floors up. The difference is the delta. Tell delta. 7 mm. These all thoroughly explained. So in this class, I will not waste time because someone will tell, not clearly explained. Go back to earlier class. It is uploaded not for fun. If you are serious, want to learn from me, study everything from first class in the YouTube. I given plenty of example for calculation of PM. You don't study anything, everything you want to give in the class. Not possible. So delta is clear. Okay, now start. First, one by one member, I write here now. Consider. Now, what you do is, before you start the solution, you first write one rough sketch. I told you. This is A. Do not write A. This is B. This is C. Little upper side. Space is not there. See. Put one sketch here. This is A. This is B. This is C. This is D. Remember, only support. You write. Overhang is not considered. This is given support settlements. Given support settlements, all are in millimeter. See, do not write A, B, C, D. Sometimes people put A, it goes to A dash. Confusion comes. Therefore, safer side. Do not write A, B, C, D. See here. A rises by 8 mm. So A will come here. See, this is the final position of A. This goes up by 8 mm. That is not delta. 8 mm. B sinks by 14 mm. Oh, it comes here. Your B comes here. Sinks down by 14 mm. Master question. C sinks by 4 mm. Okay, that's all. C comes here. This is only 4 mm. D sinks by 20 mm. Okay. D comes here, little further down. Okay, no problem. D comes here, down by 20 mm. Okay. This is millimeter, but when you substitute in the formula, it should be meter. I will tell you. Start. First, do one thing. See, I write here now. Consider AB. First, you consider AB. When you consider AB, what you do, I told you earlier. First, draw two parallel lines. Remember it? Two parallel lines. First, draw two parallel lines. Clear or not? This I told you earlier. First, draw two parallel lines. Okay. Now, tell me, which is upper side, which is lower side? Tell me. Tell me which is upper side. In the AB member, this is the two parallel lines. They are not original lines. That is, see, one parallel line here, one parallel line here. Which is upper side? A is upper side. So, Somewhere here, mark A. Remember, it is taken fixed. Why? Whatever support they give, this is the fixed end moment. When you find fixed end moment, whatever given, you have take fixed. Okay. And this is B. This is B. Now tell me, what is this settlement? No up and down direction. I do not write up and down. That settlement. With respect to A, where is B? With respect to B, where is A? Answer. Common sense will do. Answer. Do not, I won't show the calculation. Why? Somebody in the high school will tell it. 22 millimeter. Correct? 22 millimeter. But you cannot write 22. That is delta. See, this 22 is delta for AB. Clear? It is delta. 22 millimeter. I'll put here now. 22 millimeter. This is actually your delta for AB. Delta for member AB is 22 millimeter. But we do not want 22 by 1000 meter. Clear now? Because we want meter. 22 by 1000 meter. Fully clear? Fast. Fully clear. 22 by 1000 meter. If fully clear, I will continue. Fast. Okay. Now start. Therefore, if I write down, now do one thing. Draw the elastic curve. See here. Draw the elastic curve. See. This is the elastic curve. So, I told you, preventing case, if the members comes this way, I told you, suppose you drive a car. If the car slips this way, steering wheel, you turn other way. See, this member is going this way. Tell me, for equilibrium or to come back to original position, this is a crude method. I told you, preventing case, when you drive a car, suppose due to some reason, car goes this side. Turn the steering wheel this way. If the car goes this side, turn it this way. Tell me here. If it comes this way, do you require anti-clockwise or clockwise? Easy method. Refer back. Tell me. Anti-clockwise or clockwise? Earlier thoroughly told. First of all, I am wasting time. Explaining this, I am wasting time. Anti-clockwise. Someone will ask you, why anti-clockwise? I will tell him, go back to the earlier class and decide and come back. See, red color. Anti-clockwise. This also anti-clockwise. See. If it is SD method, that's all. If it is MD method, you write the formula here. How much? 6EI delta by L square. Okay, start. Now, I start here. Nodi. MAB equal to, start. M bar AB. I know the answer. It is minus 90 plus, tell me, plus or minus. It is both are anti-clockwise. You make a note here. Make a note. Both ends are anti-clockwise. Therefore, both ends use negative sign for this term. For the delta term, both ends use negative sign. Clear? Fast. Clear or not? You make a note there. Clear? You make a note there. FPM due to delta is anti-clockwise at both ends. Therefore, when you substitute here, for both ends, use minus sign. Okay, clear? Okay. Minus, so plus what? Plus bracket. One term is over now. Second term, bracket. Minus 6 into EI. EI is 16,000 into delta 22 by 1000 divided by L square. What is L square? L square is 6 square. See, you want right here, this number is 6 meter. Divided by 6 square. Tell this answer. Minus 3. Minus 90. Then minus. Tell this answer fast. Tell that answer fast. That answer fast. Don't waste time now. That answer fast. 1 is minus 90, already known. Second term, add these two, get a single term. Then remember, you write here, this is not over now. Then further, over now, FPM part is over, plus what? Tell me, this answer. You are wasting time. Those two together answer. If you do this way, I have to curtail the class, continue next time only. 9 I have to go today. 9 o'clock I have to go. Minus 92.667. 14 into 22. 14. I think I have taken some other value. 14 minus 92.67. 6 into EI. Oh, 6 is not there. See, 6 also is there. Minus 6 into EI into delta by L square. I think I should have taken. Okay, what is the answer? 92.67 is wrong. Be careful, it is wrong. I told you something. See, remember, you fell to the trap once again. See correctly. EI is 16,000. EI is 16,000. For the member AB, it is 1.8 EI. You should write 6 meter, 1.8 EI is there. You forgot this 1.8 only. Very critical. So it is 6 into, use a bracket. See, formula is 6 EI. For member AB, it is 1.8 EI is there. So 1.8 times 16,000. Remember, this mistake you made long back. Remember it? Long back you fell to the trap. Remember it or not? You fell to this trap long back. You are blind. Don't substitute. They told EI 16,000. But for the member AB, 1.8 EI is there. This I told you long back. Now tell the answer. Trapped again. Okay. Now answer. Because I got some other answer there. I know. I accounted it. Don't worry. Oh, answer first. Because I know the answer. Some other answer is there. This is deliberately I am doing. So that you should be careful. First. Minus 195.6 is correct answer. I got same. This is then further. So up to where over? This much over plus continue. 2E into, now do one thing. 1.8 I by 6 into 2 theta A plus theta B. Remember, theta A is 0. So your MAB will become minus minus 195.6 plus 2 into 1.8 by 6 into 1 is exactly 0.6 EI theta B. 0.6 EI theta B is the answer. So I will do one thing now. Space problem is there. I will write here. Your MAB, see, actually what happens is now, little problem. Okay, I will remove this one now. See, because board is problem. So I will remove this EI value all. Remember, theta A is 0. And just to understand, okay, this also I will remove. I will make it shorter. Plus 2E into I by L into 2 theta x plus theta y. So therefore, I will do one thing here. I will make a note here because I am rubbing. Continuously I will be rubbing. Okay. Continuously I will be rubbing. So I will write there, your MAB finally came. Nodi, your MAB finally came minus 195.6 plus 0.6 EI theta B came. Okay, on me. Is the visible? Visible? I will do one thing now. Because time is not there, I will write now only. So therefore this is second round, not required. Don't see here now. Your MBA will come minus 15.6 plus 1.2 EI theta B. And your MBC, this is MBA. your MBC will come, I write now only, plus 4.8, it will come, don't worry, still pending, plus 4.8. This I am writing because space problem, plus 4.8, 2 into 2, 4, 4 into 8 is 1.6, plus 1.6 EI theta B, I am still not finished, plus 0.8 EI theta C. Then your MCB will come, after 4.8, plus 124.8, plus 1.6 EI theta C, plus 0.8 EI theta B will come. Okay. Don't worry now, I am writing because why? I can remove. Your MCD will come, minus 108, plus EI theta B, EI theta C, plus 0.5 EI theta D. EI theta D. Your MDC will come. This is member by member, second member, MDC will come, minus 84, plus EI theta D, plus 0.5 EI theta C. I am writing the answer because board problem here. And lastly, your MDE will come minus, it is FPM, minus, what is the FPM? I forgot that FPM. What was the FPM for overhang? I completely forgot it. Okay. I have not written somewhere. What was that FPM for overhang? Anybody remember it? I rubbed it. What was that FPM? I can calculate once again. 12 into 2.4 plus 9 into 2.4 square divided by 2. Calculator is not on. 12 into 2.4 plus 9 into 2.4 into 2.4 by 2 is 54.72, correct? Is it 54.72? That FPM is 54.72. Is MDE I wrote earlier, is it 54.72? Tell me. I removed it because if it is wrong, everything will go. Unisha. 12 into 2.4 plus 9 into 2.4 square divided by 2. Yes, 54.72. Okay, leave it now. Start. This is answer. Therefore, this is MAB. Now write. MBA equal to, see here, corresponding FPM, M bar BA. Where is it? I removed everything. M bar BA is plus 90. Then, this term, I told for both AB and BA, anti-clockwise. So, minus, repeat the same term. 6 into 1.8 into 16,000 into 22 by 1000 divided by 6 square is the final moment plus what? 2e into I. 1.8 I by 6 into 2 theta B plus theta A. Theta A is 0. Therefore, now fast, tell me this number. Tell that number. Fast. Don't waste time. Tell that number. For MBA number, I can see there. See, I got minus 15.6. I want to check the answer. MBA number. You should tell it fast. Don't waste time. Because exact 9 I have to leave the class. I'd go a long distance. MBA, add the two numbers. You are wasting time. MBA, add the two numbers. You see, if you waste time this way, what I can do? I'll stop the class in between. MBA number, the two numbers are there, plus 90 and minus that one. You are actually not showing interest. If you do not calculate fast and give, I told I got time problem today. Minus 105.6. But I got there, minus 15.6. One of them is plus, other is minus. What you are doing? One of them is plus, other is minus. How minus 105.6? ಏನನ್ನು ಹೇಳ್ತಾ ಇದ್ದೀರಾ ನೀವು? Minus plus 90 minus 6 into what? 1.8 into 16,000 into 22 by 1000 by 6 square. You are telling all wrong values. See, you are wasting time. Unnecessary wasting my time. 90 minus 6 into 1.8 into 16,000 into 22 by 1000 divided by 36. Minus 15.6. This much time for calculation. No, you are wasting lot of time. equal to what? Minus 15.6 plus, it will come there, 1.2 EI theta B will come. Fully clear? See there, I wrote both moments. Tell me, fully clear or not? Fast. Fully clear, AB member? AB member, full clear. Fast, fast. I should finish 2 more members. Then my work is over. Once I finish all the moments, then work is over for me. You are not commenting also. Full clear? AB member, no doubt. First, FPMs are minus 90 plus 90, loading. Second term is different. Okay, now, this is also over. So, see now, these two are correct. Start. Next member. I start here now. Next member. Member BC. Okay, see correctly. Start. Member BC. I will consider here. Consider BC. When you consider BC, remember, first write a sketch here. First write a sketch. What you do? Draw 2 parallel lines. Remember, I am considering BC. Tell me, B and C, which is below, which is above? First. Which is below you tell me. Which is below? Which is below? Which is below? B is below. So, if I draw one parallel line here, B is here. So, B is here, C is here. Tell me possible, what is delta for BC? Tell me possible, what is the delta for BC or CB? BC or CB? Delta, first, see. This is 14 down, that is 4 down. Answer. Delta for BC or CB? 10 mm. Thank you. It is 10 mm. And elastic curve will come this way. If elastic curve is this way, tell correctly. See here. Member goes this way. To prevent it, preventing moment, if it goes this way, do you require clockwise or anti-clockwise? If member goes this way, do you require clockwise or anti-clockwise? These all told earlier. First of all, you should refer the old classes, where is so systematically told. Clockwise. So, both are clockwise. Be careful. Clockwise, clockwise. And chance of making mistake, member length is 5 meter and it has got 2 EI. Don't forget this 2 EI. It has got 2 EI there. Now, substitute. One by one. Therefore, your MBC equal to, M bar BC is minus 72. Then, this term is over. Second term, plus or minus. Both FPMs are clockwise. Make a note. Therefore, for both, which one? BC and CB, for the term 6EI delta by L square, use positive sign. So, it is plus, how much? 6 into EI. See, it is 2 EI here. 6 into 2 into 16,000. 16,000. Delta is 10 by 1,000. Divided by how much? Divided by 5 square. Plus usual 2E into I. I how much? 2E into 2I by, length is not 4 meter. Length is 5 meter. 2E into 2I by 5 into 2 theta B plus theta C. No zeros, equal to. Number passed. This number and this number together. Number. These two together, tell the number. Bega, bega. These two together, tell the number. Plus 48 plus 6 into 2 into 16,000 by 5 square into 10 by 1,000 plus 2E into 2I by 5 into 2 theta C plus theta B. Okay. See, I put other side. Other side is what? M bar CB. Again plus here. Plus plus. Tell the number. Single number. Plus 4.8. Thank you. Correct. It is plus 4.8. Remaining is known for you. 2 into 2 by 5 into 4 is plus 1.6 EI theta B plus 0.8 EI theta C. Okay. Same way, this will come. Will it come plus 124.8? Tell me. Will it come plus 124.8? Will the next term will come 124.8? Yes, 124.8 plus what? Plus 1.6 EI theta C plus 0.8 EI theta B. Okay, see, correct. This is also correct. I wrote correctly these two. This is actually I wrote so that I am rubbing this one now. Okay. Now, last but one member. Okay. Last but one member. But actually last member because over and nothing is there. Okay, sir. I'll write here. Consider CD. Consider CD. When you consider CD, draw two parallel lines. See, one line here, one line here. Tell me, which is upper side? First, C and D, which is upper side? And tell me delta also. Tell which is upper side and tell me delta also. Which is upper side and tell me delta also. Which is upper side? When I go for CD, which is upper side? No, which is upper side? When I go for CD, which is upper side? C is upper side, delta is 16. Why? This is 4, this is 20, difference is 16. So, it is your delta equal to 16 millimeter. First of all, 16 millimeter or 16 by 1000 meter. Remember, we are solving master question and C is upper side, D is lower side. Elastic curve will come this way. Therefore, if the member sinks this way, reacting moments are anti-clockwise. Both are anti-clockwise, anti-clockwise. Make a note. What note? FPMs for CD due to delta, both are anti-clockwise. Therefore, use minus sign for this term. See, in the master example, all terms came, some of them plus, some minus. So, on that basis, if you write MCD equal to M bar CD, M bar CD is minus 12, again minus, see, FPM over. This term is minus 6, here length is 4 meter, EI is EI only. 6 into 16,000 by 4 square into 16 by 1000. 6 EI delta by L square plus 2E into I. What is I? I is I only. I by 4 into 2 theta C plus theta D. No zeros. Same way. Now tell me answer. Tell the answer. Single number. Those two terms together. Answer. By that time, I write other one. Plus 12 minus 6 into 16,000 by 4 square into 16 by 1000. See, delta term will repeat. Plus 2E into I by 4 into 2 theta D plus theta C. Answer. That number. Don't see there and tell me. I got minus 108, correct? It is minus 108 plus EI theta C plus 0.5 EI theta D. Tell number here. For MDC number, if you tell that number, over, question over. Plus EI theta D plus 0.5 EI theta C. This is also correct. MDC number. Minus 84. Thank you. Minus 84 over. So, I wrote correctly. Now, all over. See, now I can remove this one. See, everything over. Lastly, I should not waste time. Consider DE. Make a big note. It is overhang. For overhang, delta, theta, nothing. Supported at D. Therefore, only MDE. MDE equal to M bar DE due to loading. That's all. Stop. Equal to minus 54.72. Clear? MDE equal to minus 54.7. See, that's all. Throw it outside. No theta, no delta, rising, sinking, dancing, no effect on overhang. Clear? Okay. Now, all over. Actually, right now, I can stop the class. Yes or no? Tell me. Right now, I can stop the class. Yes or no? Tell me fast. Actually, right now, I can stop the class. But anyway, I will continue. See, therefore, next step, unknowns. Unknowns are what? Theta B, theta C, and theta D. Now remember, now completely forget about all these things. You solve like a normal question. 9 basic question. Therefore, unknown at B, equilibrium condition at B is, now actually first of all, I should not talk anything, is MBA plus MBC equal to 0. See, MBA is here, MBC is here. Substitute those two, equate to 0, you will get 2.8 EI theta B plus 0.8 EI theta C equal to plus 10.8. This is your equation number 1. First of all, I should not talk about this one. Equation 1. Then, next unknown is C. This is now once again back to original question. Now you forget about the sinking all. Solve like a normal question. Equilibrium condition at C. I am writing this way because already explained for you. Is MCB plus MCD equal to 0. MCB is here, MCD is here. Add those two and equate to 0. You will get 0.8 EI theta B plus 2.6 EI theta C plus 0.5 EI theta D equal to MCB is 124.8, MCD is minus 108, equal to minus 16.8, This is your equation number 2. First of all, now you should, if it is the offline class, student will tell, sir, leave it, sir, now you can do it. Lastly, unknown at D. Lastly, equilibrium condition at D is MDC plus MDE 0. MDC plus MDE equal to 0. Substitute both of them, equate to 0. You will get 0.5 EI theta C plus EI theta D equal to MDC is minus 84 minus 54.72 equal to plus 138.72 plus 138.72. You check the equation. This is your equation number 3. Okay, equation number 3. Okay. Solving equation 1, 2 and 3. Tell me EI theta B, EI theta C and EI theta D. And then substituting, calculate MAB, MBA, MBC, MCB, MCD, MDC and MDE. All you calculate. Once you get the answer, then go to where? Tell me. All are in kilonewton meter clockwise positive. Tell me. Once you get that answer, go to where? First, once you get that answer, go to. Once you get that answer, go to where? Once you get that answer, go to where? Not go home. Go to star. Sometime newcomers will ask, sir, what is star? Star is SFD BMD, which is common for all the 3 methods. No, I can't go to MD method because already it is 838. I have to leave the house here by 9 o'clock. Long distance I have to go. Therefore, no problem. We will correctly get the moments. You solve and in a paper, you get these three values, get the moments. I noted the answer there. You now solve it. Take a calculator, you tell me the answer. EI theta B, EI theta C, EI theta D, and rough paper, prepare the moments for second decimal accuracy. Next time when I solve MD method and Kadi's method, infinite percent same answer will come. Agreed? Infinite percent guarantee, not 100%. Infinite percent guarantee. I can risk my life. I will risk my life for it. Same answer will come in MD and Kani. Yes or no? It will come because it is my class. My class, no question can escape. Okay, now do one thing. I will take a small break now. You correctly get ready in a paper and type the value of EI theta B, EI theta C, EI theta D. Leave some space and type the moments. Agreed? In the order, first you type three values. Thetas, then write moments are so and so. Okay, agreed now? Don't stop the class. Because I do not want a question to be incomplete. If it is a usual class, our class in the Zoom, our batch class means I can stop. But general public, they will tell. Everything is told. Finally, moment is not done. Food is prepared. Finally, dining is not, food is not served. No. So therefore, I will take 5 minutes break. Okay. You get correctly and solve. Go through this question repeatedly and completely clear. Tell me. This question completely clear. Analysis of continuous beam when support settlements are given. Completely clear means get ready next time for moment distribution method and Kani's method. I will come back after 5 minutes. Okay, stop. I will come back after 5 minutes.
I want to put the mic because my closing part. Tell the answer. Okay. Hope you can faintly hear. Mic not required. EI theta B. How much? EI theta B. Don't waste time. If you tell earlier, I can go earlier. You are helping me. If you are helping me to go a little earlier. EI theta B. You are not doing. EI theta B. See, this is called no response. See, I told you solve fast. If you tell the values, I can go fast. You are helping me then. So that I can go a little earlier. EI theta B. No answer. Okay, see. That shows what is this. I already formed the three equations. It will take not more than 2 minutes. Still you are not solved. You have decided that I should be delayed as much as possible. Did you decide that way? No. Let him go as late as possible. Still no answer. I want to confirm it. I know the answer there. I want to confirm it. I already solved earlier. Usually I don't solve it in the offline class. I don't solve because my people are here only. Here I solved because to save the time. Again you are not giving answer. After asking so much also, you are not giving answer. What to do? Okay. Get EI theta B, EI theta C, EI theta D. 335. 335. No. It is not 335. Wrong. I know the answer there. That much theta will not come. Wrong. 35 point. My answer is 15.8768. How 35 point? My answer is EI theta B is plus 15.8768. EI theta C is minus 42.0687. EI theta D I do not know because I got a trick of eliminating that one. Anyway, you check later. Agreed? If it is wrong, next time give correction. Nothing to worry. See, now if there is a mistake, it is not called technical mistake. It is called calculation mistake. So, next time you tell me correct or not. Because if wrong, I will correct it next time. Agreed? Theta B is 36. I got 15.8768. Okay. Nothing to worry now. Too late. Okay, I will do one thing now. I won't write any answer. I will put the moments. MAB is minus 186.07. MBA is plus 3.45. MBC is minus 3.45. MCB is plus 70.19. MCD is minus 70.19. MDC is plus 54.72. MDE is minus 54.72. Okay. Subject to check. Agreed? No. Something wrong you have done. Why worry? Subject to check. If these values are wrong, next time when I take MD method, I will tell in the class. See, previous class solution was wrong. So the revised values are so and so because MD, LD, Kani, they cannot deviate. No, okay, leave it now. No point wasting time. In case this is you check later. If it is not correct, let me know next time. Next time I write here. See, previous class. Structurally no mistake. Technically no mistake. Calculation point of view, equation solution, something wrong. So you correct it. Then I will write correct moment here. Because LD, MD, Kani or any method. I told in my class, for that matter, in everybody's class, if he is taking subject correctly, should come same. Different value cannot come. Agreed? Okay, thank you. Anyway, you in the group you comment it. In the group, indeterminate structures group, you tell me whether my answer is correct or wrong. See, it is somewhere there. Tomorrow I got ETAP class, tomorrow and Sunday, so this I am rubbing out. But the right side corner note down, I will not rub it. It will be there only. I need board only up to here for ETAP class. So those things I don't require. This question, I will take a photo. Question, I will take a photo and write next time once again. Okay, thank you. Getting late. Something wrong you have done. Check it. You do one thing. You check it and comment it in the group. Agreed? Comment in the group. You comment in the group. Someone told no, correct. 15.8762 668 42 point. Now see, now answer came. Correct. See, I told because usually I don't make mistake in the solution. If it is wrong, I can make out. Okay, done. Thank you. Next class I will do MD method. Other class I will do Kani's method. And Kani's method, FPMD repeats. Therefore, I will draw SFDPMD on that class only. Okay, thank you.